Okay, exam one will be postponed. If Wednesday, the campus is open, we're going to do on Wednesday. If not, we're going to keep postponing. So today we're going to talk about chapter 5, discrete probability distribution. We're going to cover section 1 and section 2. Can anyone remind us what does discrete mean? Remember, we have two kinds. We have numerical variables, but numerical variables can be discrete, can be continuous.
A discrete is a countable amount. Like the
Good.
example would be like the number of points scored in a basketball game or something like that.
Yeah, it's a whole number. You can count it with a whole number. You can count it like 1, 2, 3, 4, 5. Right, so that's with the numerical data type. Right, we have discrete means countable. You can count it with 1, 2, 3, 4, so on and so forth. And versus continuous. Right? And the song we're going to talk about continuous. Continuous means it can be measured, like a time, length, area, volume, can be measured, can be calculated. Okay, great. So we're going to talk about describe a discrete random variable. Okay, what does the word random mean? Remember, for data science, not data science, statistics, right? The process of statistics, the first step is to, well, maybe you want to form a hypothesis, right? But you don't, sometimes, a lot of studies, you don't really have to form a hypothesis. But if you need to form a hypothesis, that would be your first step to form a hypothesis. If not, we'll be collecting data. Okay, so when we're collecting data, we need to do something called a simple random method. So this random comes from there. Simple, we need to do simple random sampling method. Which we'll talk about later in this textbook. And that's how this course is designed. If I would design it, I would probably start with hypothesis, then collecting data. I will follow the steps of statistical process. But we have to follow this. So when you collect data, right, you don't want to collect biased data. And you want the data to be able to speak for any data in the data set. You want to pick up the sample to be good representatives for the population. And people studied this, they formed a couple of good methods. So overall, it's called a simple random sampling method. Cluster, strata, we'll talk about later, all right? So this random from there. Okay, this random from there. So suppose, the data was collected are simple random samples. They're good representatives for the population. So then we have variable, right? Because we could have our data set, we usually have data set, not a single one. So we need a variable to represent each value in the data set. Then discrete means countable. So you can imagine this in this data set, the variable could be 1, could be 2, could be 3, could be 4. That of course can be 0, right? Can be 0. So whole numbers represented with whole numbers. And so this is this part, right? Discrete random variable. You can imagine you are studying, I don't know, you want to check out how many classrooms on the campus, right? You can count the classrooms. And for how many you can represent with 1, 2, 3, 4, right? You can name that number of classrooms to be a variable. Then probability distribution. Remember we talked about the data center. The center of a data set, we have three measurements, mean, median, mode. We talk about the standard deviation, how the data spread it out, the dispersion of the data set. Now we have one more thing we call probability distribution. In class, we didn't mention, because of the empirical rule, we didn't mention one of the probability distributions, which is called a normal distribution, the bell curve. So this is one of it. And this is continuous. This is for continuous random variable. We did talk, but this is one probability distribution. We have tons of probability distributions. We're going to talk about uniform probability distribution, means for every data, the value is the same, right? Imagine in a data set, student's age, in a class, it happens, everybody to be 18 years old, right? That would be uniformly distributed. Or maybe the data set, distributed like a curve, well, or something else. So that's called probability distribution. How data, well, just picture is like a picture of the data set. Okay, let's talk about this one, the first section first. Okay, let's read this. In this chapter, we extend our discussion about probability by introducing the concept of a random variable, right? Random variable, just a variable. Random comes from this variable represents the good data set. And this data set are randomly sampled from the population. Well, for us, you just know it's a variable, okay? Whenever you see random variable, it's a variable. The variable can represent a good data set, any member in a good data set. Random variable summarizes the results of an experiment in terms of numerical values. But discrete variable and continuous variable are continuous data type. It can be classified as discrete or continuous, depending on the range of values that assumes. A discrete random variable assumes a countable number of distinct values, whereas continuous random variable is categorized by uncountable values within an interval, right? Can be measured, can be calculated. In this chapter, we focus on a discrete random variable and its associated probability distribution. Examples of discrete random variable include the number of salespeople who hit the target for the quarter, the number of refinance applications in a sample of 100 homeowners, and the number of cars lined up at the two booths, so on and so forth. We calculate summary measures for discrete random variable, including its mean, variance, and standard deviation. Using properties of random variables, we are able to apply these summary measures to describe portfolio returns, which means, we want to collect good data. So those data are random data, and then they're good representatives for the population.
Hello,
So,
Professor.
yes. Hello.
Hello. I'm making sure you took attendance. I'm sorry. I just finished shoveling snow.
No, 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 no. Later I'm going to take attendance.
Okay.
Yeah. Uh, so this sentence means we want these good samples speak for the whole population. So finally, we discussed three widely used discrete probability distribution. Okay, binomial. Bi means two. Nomial. So binomial. Right. Think about a typical case is you have a coin. Let's say you have a quarter in your hand. You can toss this quarter. You can toss this quarter. Then you either get head or tail. We assume this quarter never lands on the side. Okay, that's binomial. So you only have two possible outcomes or two types of data, so on and so forth. So bi means two. Then the Poisson distribution. Okay, we'll see. Poisson is a little bit complicated, and the Poisson has a formula, and the hypergeometric distribution. Okay, so at least we want to understand those three. So binomial, Poisson, and hypergeometric. Starts with a question, problem. So this is the definition of a random variable. A random variable is a function that assigns numerical values to the outcomes of an experiment. A discrete random variable assumes a countable number of distinct values. A continuous random variable is categorized by uncountable values in the interval, right? So discrete can be counted, and the continuous can be measured or calculated. When we talk about probability distributions, we know, so the structure of probability is for any, so this is event, right? The probability of any event is from 0 to 1. It cannot be less than 0, or 0 means it never happens, right? 1 means 100% happens, it's going to happen, it happens. 1 means 100%. So 0 means not happening. So the probability of each value of x, remember x is a random variable now. This works for discrete and also continuous. Whenever we talk about probability, the probability is a structure. So probability is a mathematical structure. The values goes from 0 up to 1. So you can imagine it's a decimal, right? Because probability is like a percentage. It's like it's a part of something over the whole thing. So the whole thing is a sample space. It's everything, right, in the sample space. And this is the desired, the numerator is the desired event, desired outcomes. The bottom is the number of all outcomes. The numerator is the desired outcomes. This is always a fraction because it's a part of the whole thing. It can be, the part can be whole or part can be nothing. So that's why the extreme values are 0 and 1. The sum of the probability equals to 1. Right? What does this mean? This means if I have a probability of the first event to be something, probability of the second event to be something, and add them all up, it has to be 1. It cannot be less than 1. It cannot be more than 1. Otherwise, it won't be a probability structure. Probability is a mathematical structure. Probability of any event is in between the value in between 0 and 1. Add up probability of all possible events or all possible outcomes, that has to be 1. So with these two, that forms probability structure. All right, so you could see this, right? Sum up the probability of all events. It has to be 1. Cannot be less than 1. Cannot be more than 1. Okay, basically that's the definition. That's the definition of probability structure. Let's see this example. Suppose we roll a 6-sided die. Remember 6-sided die. Right. It's like a cube, right? Maybe a little bit smooth around the corner. And we have 6 sides, so the value goes from 1, 2, 3. Sometimes they use dot, like a little dot represent 1. They put 2 dots represent 2, 3 dots represent 3. 1, 2, 3, 4, 5, 6. So 6 values. So we will say when we roll a die, we have a 6 possible outcome. So we say, sample space. And we call that sample space. Sample space equals, we use this set notation. Set notation. We use this wiggly bracket. 1, 2, 3, 4, 5, 6. Right, so when we roll a die, once the sample space is this, so possible outcomes, all possible outcomes means the sample space. Imagine when we roll this die, right? Can be 1, can be 2, can be 3, can be 4, can be 5, can be 6. So the question is asking, okay, suppose we roll a 6-sided die and define the number rolled as a random variable, right? You can imagine now we have a random variable x. X can be 1, x can be 2, x can be 3, x can be 4, x can be 5, x can be 6. Present the probability distribution in a tabular form, in a table. Well, the sample space we have, so the sample space, the number of sample space, or the size of the sample space, you see cardinality. Cardinality of this sample space, which is roll a die once, equals to the 6, right? Because 1, 2, 3, 4, 5, 6. And it can be 1, so it's 1 out of 6, right? When we desire the event to be 1, and the sample space is 6, is a 1 out of 6. So part of something over the whole thing. It could be 2, there's only 1, 2, right? Still 1 over 6. It could be 3, 1 over 6. Could be 4, 1 out of 6. Right? So the probability, so this will be the probability distribution for the random variable to be 1, to be 2, to be 3, to be 4, to be 5, to be 6. So this is called uniform distribution. Right? If we draw the graph, 1 could be 2, could be 3, could be 4, could be 5, could be 6. So this is a variable. Then probability we use P. Okay, so this is P of X, probability, all 1 out of 6. So for everyone, right? For 1, I shouldn't draw continuously. I should draw the probability. It's just every, so right, the probability is the same. The same. So that's it. So this is probability distribution for rolling a die once. Right? Because we may be, roll twice. But when we roll twice, the probability distribution will be different. All right. If anyone has any question at any moment, feel free to stop me. All right. So that's one situation. That's one example. So this table shows cumulative probability, but you just add up the previous one. So what does this mean? How do we see the probability of this? So this is the probability of X equals to 1, the first one, right? This is the probability of X less than or equal to 2, which means it could be 1, could be 2. This accumulative means the probability of X less than or equal to 3, right? Could be 1, could be 2, could be 3. So on and so forth. So let's just use this example. What is the probability when X less than or equal to 3? That's the probability of X equals to 1 plus probability of X equals to 2 plus the probability of X equals to 3. Then this will be a cumulative X, the random variable less than or equal to 4. less than or equal to 5, less than or equal to 6. Well, less than or equal to 6 is 100%, right? Because there's a probability of x equal to 1 plus equal to 2 plus equal to adding all of them. Then maybe we can ask a question. What is the probability to get, so what is this question? What is the probability to, what's the probability of the random variable is 3? This is another way to find it, right? You find the probability of x less than or equal to 3, which is means 1, 2, 3, minus the probability of x less than or equal to 2, which means 1 and 2. Then you're only left with probability of the random variable equals to 3. But if you are given this table, you're not given 5.1 table, because this is cumulative. How do you find the probability of x equals to 4? With this, you use probability of x less than or equal to 4 minus probability of x less than or equal to 3. Right, because this first one is from 1 add up to 4. This is 1 add up to 3. When you subtract, you get a random variable equals to 4. So we use this kind of notation to represent, to describe the probability distribution. Okay, so probability distribution is a function. So probability of x equals to some value gives us 1 out of 6. Right? If x equals 1 or 2 or 3 or 4 or 5 or 6 or 0 otherwise. Because die doesn't have any other numbers. Anyone has any question? So when you roll a die, what's the probability you get a 7? 0. All right. You see, everyone has the same probability. Let's see this example. The number of homes that a realtor sells over a 1-month period has the probability distribution. Okay, you see table name, title, right? Probability distribution for the number of houses sold. And this will have this distribution table, number of houses sold, then probability. Right. Remember before when we talk about a frequency table, we have one called a relative frequency. And that's it. We don't call it relative frequency anymore. We call probability, because relative frequency, it is the probability, all right? So relative is a part of something over the whole thing. Okay, so this is the number of houses sold. So the no house probability is 30%. So the one house, 50%. 2 houses, 15%. 3 houses, 5%. So let's make sure this is a probability structure. First, every value is in between 0 and 1. So the first condition met. Second, this has to add up to be 1. If it's not 1, it's not a probability structure. So 5 plus 5, 10, carry on 1 here. 1, 2, plus 8, 10, carry 1 here. Bingo. It is 1. It's 1.00. Yes, it is probability distribution. So now let's answer the questions below. A is asking, is this a valid probability distribution? Yes. Satisfies the 2 conditions. The first condition is every probability here is in between 0 and 1. Second is they add up. We add up all this, we get 1. B, what is the probability that the realtor does not sell any houses in 1 month period? 30%. Right? Because 0.3 is 30%. Usually we use a percentage to represent. Right. if you see, oh, what is the probability the realtor that use 0.3, that's fine, but it's kind of weird, right? So usually we tell people 30%. What's the probability that the realtor does not sell any houses in 1 month period? About 30%. So C, what's the probability the realtor sells at the most one house? At the most one house, which means no house or one house. So add those to 80%. Pretty high. So 1 month period, the realtor doesn't sells at the most one house is 80%. D, what's the probability that the realtor sells at least two houses? At least two houses. So 0, sell none, or sell one, or sell up to two. So add those three. 95%. Right? 0.3 plus 0.5 plus 0.15 is 0.95, which is 95%. Okay, lastly, seeing graphically depict the probability distribution and comment on its symmetry or skewness. Okay, symmetry means something symmetric. We have a line of symmetry, right? Maybe the line of symmetry vertically, maybe the line of symmetry horizontally, maybe the line of symmetry somewhere. So if I have this one here, let's see here, you have this one here. So this symmetric to this line of symmetry, right? You have something here. The symmetric with this vertical, you have something here. Symmetric with this horizontal. Right? Symmetric means if I have line symmetry along the line of symmetry, I fold the half to the other, the overlapping. Skew means, shifted to the right or shifted to the left. We see skew to the left or skew to the right. Right, so we just draw a picture like this. Probability for getting 0, so the horizontal one is how many houses being sold. You see, we call this a figure 5.2. Then we have title. We have label for x-axis. We have label for the vertical axis. The vertical axis is a probability. If we want, we can put a probability of x here. This one can put x here. X can be 0, X can be 1, X can be 2, X can be 3. So probability of sell no house, probability of X equals 0 is 0.3, 30%. Probability of X equals 1, 50%. Probability of X equals 2, 1.15. Probability of X equals 3, just 0.05 or just 5%. Anyone has any questions? Okay, so now when we talk about probability distributions, right, we say it's a function. Now we care about it's a function. So before, what we do with the data set, we have a set to do to find the center, to find the standard deviation. And now also with this distribution, probability distribution is the same thing. And we like to talk about certain terms. The terms including expected value. All right, so this is a new term to us, expected value. And a variance and standard deviation. Because now we can form it to be a function. A function is a model because the data set can be modeled. The data set can be described with a function. So we have an easier way, much easier way to calculate the variance and standard deviation. And now we have a new term, expected value. So what is this expected value? to another measurement. Expected value. So this is one of the most important probabilistic concepts that in statistics is that of the expected value, also referred to the population mean. All right. Right. I don't know what's your background. Like usually when we talk about expected value, a lot of time we use in games. Imagine someone goes to a casino, right? They want to play something called a blackjack. I'm not sure if I spelled this jack right. So you better calculate expected value. So in that case, expected value tells you what is your chance of winning or what is your chance of losing. If your expected value is 0, that means it's a fair game. So either party has a 50% chance of winning or losing. If you calculate from your standard point, you get a positive value, that means you have more chance to win. If you get a negative value, that means you have more chance to lose. Of course, all casino games, expected value are negative.
So the expected value is like what's it called? Uh, the margin of error.
The margin of error?
Yeah, is it does it kind of work like that?
Okay, that's good thinking. But they are using different context.
Okay.
Okay, they're using different context. But yes, I think that's a very good thinking.
Okay.
Okay,
Thank you.
you're welcome. But from now on, let's remember this. What is expected value for us is the population mean. Remember that? The sigma. Is a sigma? Oh, no, it's a mu. It's this notation. Remember sample mean, we use x bar, right? So population mean, we use this mu. Do you know how to write this? You see, this is u, lowercase u. You just do this one a little bit more. Right? Mu is pronounced as mu. Mu. Anyway, so from this moment on, let's remember that the expected value is the population mean. The population mean value. The expected value of discrete random variable x denoted by E of x. E of x. Or simply mu is a weighted average of all possible values of x. The mean mu of the random variable x provides us with a measure of the central location, the center of the distribution of x. But it does not give us information on how the various values are dispersed from mu, right, with standard deviation. We again use the measures of variance and standard deviation to indicate whether the values of x are clustered above mu or widely scattered from mu. All right. So variance. So now we need to get familiar with this. Consider a discrete random variable x. So usually the random variable use capital letter. So we use a capital letter X represents the random variable. With values could be the first one, second one, third one, so on and so forth, which we write like this. So with discrete, we can write, as a probability of the capital letter X equals to certain value, right? So equal sign. And you can imagine later on when we do continuous one, we're not able to use the equal sign anymore. We can only use the intervals. We have to use intervals, x in between two numbers. Or x like x less than, x greater than, or with the equal sign. Doesn't really matter with a continuous one. With continuous one, right, this is with a value, and it'll be same as less than C. Because when it's continuous, we don't consider the probability at one point. At one point, only for discrete. All right, it could be in between two values. So this with continuous. This notation with continuous. This may be A, this may be B. All right. But with discrete, we do have this equal sign. So this is precious, right? So whenever we see X equals to a value, we know that's a discrete. We're talking about probability with discrete random variable. This means it is a sum of all the weighted mean. Like when I calculate grades, right? You have exam 1 grades, you have exam 2 grades, you have final grades, then you have a homework, you have project, and each one carries a certain weight. I don't know if I remember right. Maybe this is 0.15, 0.15, 0.20, 0.30, then that's 60, so this has to be 0.20, right? So then probability of this times this weight, probability of this times probability, times how much you gain. Let's say you gain 80 for exam 1, 90 for exam 2, 100 for final, 100 for project, homework 100 also. So this will be value of that. This is a probability of that. So that means xi here represents your grades for each category. And the P of x equals xi represents this probability, right? So multiply 80 with 0.15 plus 90 times 0.15, so on and so forth. So that's weighted, that's why it's saying weighted mean. Sometimes the weights could be the same, right? Okay, so that's expected value, which is population mean. How do we calculate? We calculate it from this. So the second one is the variance of the random variable, and denoted as sigma square or var of x, right? Use the sigma square. So how do you write this? You write like a O, then you give a little bit this on the head. All right, that's how I write it. Sigma square is variance. Well, sigma is a standard deviation. When we square root of the variance, we get a standard deviation. So how do we calculate? We calculate with this. We calculate with the data value, subtract the mean. Remember, I have done this when we talk about standard deviation, right? The data for each data value, subtract the population mean. Subtract the population mean, square that value, multiply by its corresponding probability. Right? Then add them all up. Add them all up. You see now we're in probability distribution. We do not have add up divided by n or divided by n minus 1 divided by n. We don't have that. Okay, but we have this probability. We have this probability now. Probability, and also probability is always a part of something over the whole thing. Right? It's a decimal in between of 0 and 1. So instead of before, which is dividing by n or n minus 1, now we multiply by its corresponding probability with each data value. So same thing for the variance, right? The difference with square, we multiply by its probability. Okay, lastly, standard deviation is easier, just square root of the variance, right, which is sigma. Anyone has any questions? Let's see an example. Brad Williams is the owner of a large car dealership in Chicago. Brad decides to construct an incentive compensation program that equitably and consistently compensates employees on the basis of their performance. He offers an annual bonus of $10,000 for superior performance. So let's underline this. $10,000 for superior performance, $6,000 for good performance, $3,000 for fair performance, and nothing for poor performance. Based on prior records, he expects an employee to perform at superior, good, fair, and poor performance levels with a probability of 0.15, 0.25, 0.4, 0.20, respectively. So table 5.4 lists the bonus amount, performance type, and the corresponding probabilities. Right, so good habit, give a table a name, give a table a title, probability distribution for compensation program. And the first column is a bonus in 1,000s. Right, we have 10,000, 6,000, 3,000, and no, none. And performance type we have superior, good, fair, and poor. Probability we have 15%, 25%, 40%, and 20%. Now, let's go to the questions. Question A is asking, calculate the expected value of the annual bonus amount. Well, let's remember that. Expected value, we use E of X, capital letter X, expected value of the random variable X equals to, right, mu equals to sum of all the data value minus the mean. Oh, hold on a second. I'm doing the variance now, not the minus. The data value, right? I depends on how many i's. We'll count how many i's. 1, 2, 3, 4, right? So then multiply by the probability of xi. So what do we have? We have 10 times 0.15 plus 6 times 0.25 plus 3 times 0.4. Well, 0 times anything would be 0, so we don't need to write it. 10 times 0.15 is 1.5. 6 times 0.25, well, that's a 1.5 also, right? Because 6 is 4 plus 2. 4 times 0.15 is just 1. 2 times 0.15 is 0.5. So then plus 3 times 0.4 is 1.2. So I have 1.5 plus 1.5, 3. 3 plus 1.2 is 4.2. So that is the expected value. So which is the population mean. So what does this mean? This so this is talk about for all populations, not for the sample, right? So it's expected. So picking randomly pick an employee from this company, and he's going to own, likely he's going to own 4,200, because this is in thousands, right? 4,200. So that's what the expected value means. He's expected, okay, to have the bonus of 4,200. Okay, let's see B. Calculate the variance and the standard deviation. For the variance, we just follow the formula. Variance, we use sigma square or var, VAR of x. Usually we use sigma square, right? That equals the sum of each xi minus the mean square, then multiply by its corresponding probability. So we need to calculate. So we need to calculate 10 minus 4.2 square times 0.15 plus 6 minus 4.2 square times 0.25 plus 3 minus 4.2 square times 0.4, right? 10 minus 4.2 get a positive number. 6 minus 4.2 get a positive number. 3 minus 4.2 get a negative number. But because we have a square the negative number, we also get a positive number. Okay, I don't want to calculate this, so I'm going to go to the textbook to see that calculation. Right? So they use this table to calculate. So this is the mean. I don't know why this red total. Just read this mu equals to 4.2 sigma squared, the variance, right? Or 0 over, I didn't write 0 minus 4.2 squared. It just becomes a positive 4.2 squared. Then add them all up to get 9.97. Anyone has any question? Okay, lastly, it's asking what is the total annual amount that Brad can expect to pay in bonuses if he has 25 employees? What's the total annual amount that Brad can expect to pay in bonuses if he has 25 employees? Well, the total number is just 25 people. So remember, the expected value is 4.2 thousand, which is 4,200. Well, if he has 25 employees, right, each one gets 4,200. So just multiply 25, get a 105,000. Right? So he has to, he can expect to pay this much money in bonuses for his employees. Anyone has any questions? Okay, let's keep moving. So those are some finance terms, right? Risk neutrality and risk aversion. So an important concept in economics, finance, and psychology relates to the behavior of consumers under uncertainty. Consumers are said to be risk neutral if they are indifferent to risk and care only about their expected gains. Okay. To be risk averse if they care about risk and if confronted with two choices with the same expected gains, they prefer the one with lower risk. Okay. So risk neutral only concerns expected gains. Risk averse, care about risk. They pick the lower risk to go with. Risk-loving consumer may be willing to take a risk, even the expected gain is negative. So these are three types of risk takers. Risk neutral, right? They care about expected gains. Risk averse, they care about risk. They pick the lower risk to go. Risk loving, they care about if talking about the financials, they care about the returns. They don't care if the expected gain is negative. There's a little summary here. All right. So a risk-neutral consumer completely ignores risk and makes their decision only on the basis of expected gains, which is the population mean. Risk-averse demands a positive expected gain. Right? They care about the risks. They pick the highest expected value to go with. Risk-loving may be willing to take a risk even if the expected gain is negative. So those are brave ones. Let's see this example. You have a choice. Oh my goodness. Oh yes, I did record. I thought I forgot to record. Yes. You have a choice of receiving $1,000 in cash or receiving a beautiful painting from your grandma. The actual value of the painting is uncertain. You are told that the painting has a 20% chance of being worth $2,000, 50 chance of being $1,000, and 30% chance of being $500. What should you do? Okay. So we could make this table with table name, with table title, probability distribution for the value of painting. Then this is a random variable with value, and this is the probability, right? So probability of the painting worth 2,000 is 20%, is worth 1,000, 50%, or worth 500, 30%. We calculate expected value. 2,000 times 0.2 plus 1,000 times 0.5 plus 500 times 0.3. So we get 1,050. So basically this is saying he can expected the painting to be sold for $1,050. Right now, well, either receive 1,000 cash or expected to get 10,050 by selling it. Since the expected value of the painting is more than 1,000, it may appear that the right choice is to pick the painting over 1,000 in cash, right? This choice, however, is based entirely on the expected value of painting, paying no attention to the risk. So what kind of, if the person do choose this, what kind of consumer is he? He will be a risk neutral one, right? He will be a risk neutral one. All right, and yeah, that covers 2 of these sections. Anyone has any questions? Next class, we're going to talk about the binomial distribution. And anyone has any questions regarding to today's material or regarding to exams? Exams postponed to Wednesday. If Wednesday school is open, we're going to have first exam on Wednesday. Any question? I heard something.
You said exam on Wednesday?
Yeah, it
Okay.
was supposed to be today.
And just to clarify, it was only covering 1 and 2, right?
That's right.
Okay. Thank you.
Sure. I post a video if some of you missed the class of reviewing. Okay, any other questions? I'm going to stop recording this, okay?